Okay, let's do this. So the first thing that we're going to do is radicals. So we're just reviewing radicals. Apparently this slide doesn't want to work, but I have it up here. So what does it mean when you read evaluate? So solve it. Take the calculator, punch in your calculator, or just know what it is. What's the square root of 121? 11. So evaluate, you would just put equals 11. If you did the cube root of negative 64, what do you get? Negative 2, negative 4, positive 4. Punch in your calculator, check. 4? Is it negative or positive? Negative. Why can you get a negative when you root something? Yeah. So we got the cube root.
It only works if you have an odd index number, because if you have an even one, then it's...
And that's what I was looking for. So when you're doing a root of something that's negative, it's only possible if your index, that's a little number, is an odd number. So if it was an even number, it wouldn't work. And your calculator should send back an error. If you did this in your calculator, you should have got that it's negative 4. And I hope that your calculators are giving you the right answer. And my writing is going to be really messy today before it gets to calibrate. The last one. Fourth root of 81. 3. Really basic, right? The idea is to remember what the word evaluate means. Okay. This class is a lot about knowing what you're actually being asked. It's not going to say what is, it's going to say evaluate. So no little tricks like that. Oh, this is so brutal. Want to grab it from me? Okay, the next slide. Apparently nothing. It's going over definitions. And this slide is probably a good one to just kind of star and go back to if you ever get a question where you don't know what's being asked. Odds are there's a definition on this page that you don't remember. So the actual sign that you see is called your radical symbol. So that root sign is a radical symbol. The little number, like I already said, is the index. And the number underneath it is the radicand. The entire thing combined is called a radical. So it doesn't need to be a square root or a cube root or a fourth root. Anything under a radical sign is a radical. Okay, go to the next page. My slides aren't working. Compare and order radical expressions with numerical radicands in a given set. Basically, you're just going to order them from smallest to largest. Yeah. A cheap way out of this, use your calculator. Punch it in, get a decimal. Yeah, like you could literally just put those into your calculator and get a decimal for each one, and then order it out. Odds are they're going to find a way to not let you be able to do that. So you need to know a different way of figuring out which one's the smallest and which one's the largest. Anybody have any ideas? Just a second. Hello?
Yeah.
Yeah, for sure. Do you want to get your timetable changed? Yeah, he does. I don't. Right. Go ahead. I just see Garrow. Okay, what's your idea for?
If they have the same index number, then you can just convert them into an entire radical.
Yeah, that's a perfect way to do it. So if they have the same index value, so what she means is if the little number is the same, which they all are, they're not existent in this first one, which means the little number is a 2. The index is a 2. She says convert them all into whole radicals, entire radicals. Anybody remember what that means?
Well, I don't know how to explain it, but I know really quickly.
Yeah, that's fine.
Take like the 9 and then times it by however much the index is, and then times it by the number is.
Exactly. So an entire radical doesn't have this little coefficient in front of it. This right now is called a mixed radical because it's got a coefficient and it's got a radical. We want to convert it into just a radical. So what we have to do is put this 9 underneath the square root. So that's what we're going to do. We're going to go square root, and the 2 is still going to be there. But now we need to put the 9 in there beside it, so we're going to put 9. That doesn't actually, let's try this again. Square root, the 2, and we're going to times it by the 9 that we brought in. But that doesn't work. What do we have to do? What else do we have to do?
Square the 9.
We got to square the 9. So since we brought that 9 underneath the square root sign, we need to square it. And depending on the index, depends on what value you put right there. So if you put, for instance, cube root, then you would cube it when it came in. If you had a fourth root, you put it to the power of 4 when it came in, and so on and so forth. Try those first 3. Try to change them into entire radicals on your own, and then I'll give you the answers. I'll try to calibrate this thing real quick. Some better notes here. So if we're converting that first one, I said it would be the square root of 2 times 9 squared. You don't leave things like that, right? Your 9 squared would be 81, times it by 2 would be 162. So this would change to the square root of 162. That'd be the first one.
So you
only square the 9, yeah. So I'm going to walk us through this next one a little slower and do a little bit better writing because I can actually write on it now. So we want to take 2 times the square root of 6. The trick is you're going to take this 2 and you're going to add it underneath. So let's do that. So it's now 2, black, 2, times, square root of 2 times 6. Yeah. What happens if you square root a decimal? Does the number get bigger or smaller? Try it. See what happens. Square root of 0.1. Try your calculators off for us. What else do we get? Square root of 0.1. So the square root of 0.1 became point what?
3, 1, 6, 2, 2, 7, 7, 6.
What happens when you square root a decimal? It gets bigger. 0.1 got bigger. Which seems kind of strange, right? Like, why would it get bigger? And you can kind of think of it as the same way when you square a decimal. So like 0.2 times 0.2 gets smaller. This is just going backwards. So the square root of something, that's a decimal, will get bigger. That'll help you if you end up getting decimals you don't in these questions. But you might. You might start seeing the square root of fractions in those problems. Or the cube root of fractions. So you're dealing with numbers that are actually less than 1. No. So we're not going to convert to decimals very often in this class. You might have a question that asks you at the very end to convert it, but when you're doing written work, leave it in a fraction. Leave it in a fraction for us. That's considered an exact answer. And a lot of you here are going to move on to post-secondary, where you probably won't be allowed a calculator, and you probably won't ever put things in the decimal. Yeah, didn't do anything in decimals? No. Where you guys are headed, where the majority of this class is headed, you're not going to be allowed to, so we might as well just start getting used to it. So that one day when you show up at a college course and they tell you to put your calculator away, you're not just completely thrown away. That's what we're trying to train you guys for. Okay. How do we feel about, do you guys want to do one more as a group, or do you want to see if you can do it on your own, and I'll show you the answers? Hand up, 5 if you feel comfortable right now. 4 if you're not. 3, 2, 1, go up and down. 1 means that I need to see another one done. Okay, try this next one on your own. Order it from least to greatest. Try it on your own without putting it into your calculator. So convert each one of these. So like this first one? Yeah, so it would be 7 to the power of 3. Try ordering them on your own by converting them into entire radicals. We'll do these quick. I'm just going to convert them, and then I'll probably order them real quick. First one is going to be the cube root of 3 times 7 to the power of 3. What do you get when you punch that in your calculator? The square root of what? 1,029. The next one is going to be the cube root. Sorry, I lost my cube root there. The cube root of 3 times 3 to the power of 3. So 3 to the power of 3 is 27. Times 3 again is 81. The third one, the 8's coming under, so it's going to be the cube root of 3 times 8 to the power of 3. 8 to the power of 3 is 36. So we're going to do the cube root of 1,530. Hope you guys are getting the same answers. You're marking yourself. Question C. You notice that they're different indexes. You can't just look at the number underneath the root sign to order them. You would need to convert it into a decimal or know roughly what they're going to be. This first one, though, because we're going to practice our converting, is the cube root of 2 times 7 to the power of 3. What you get? 7 to the power of 3 times 2. 86. The next one is the 4th root of 5 times 6 to the power of 4, which is, what is it? 6480? Yeah. Not 6,480? Yeah. It's a weird way to say number. And the last one, you're doing the square root of 5 times 4 to the squared. So you're doing the square root of 5 times 16. 80? 80. So it should be the 3 answers. You can't order them by eyeballing. Those of you who punched it into decimals and then ordered them, what was the smallest one? First, this one was the smallest one? So that was the smallest one. Second smallest one. It doesn't work out from smallest to largest, just based on the number underneath the radical sign. Okay, hopefully that's Some nice easy review. We're gonna move on a little bit, but it's still basically the same. We're gonna just move on to fractions. This rule right here. Started. Now you look at that, that kind of looks brand new to you. Probably a good idea to start. This is actually just an exponent rule. Basically. That's the way you think of it. Because the square root is just the power of 1/2. So like two things to the power of 1/2 times each other. That's not ringing a bell, don't sweat it. Just remember that rule and you'll be good. Example 1, express 5 times the root of 3 as an entire radical. In order to multiply the values, both must be the same radical form. That's exactly what we've already basically done. So you're good. Go below. Write each mixed radical as an entire radical. We're pretty good at that. We just did that last time. The only thing that might be different to you guys is a negative. What happens when you bring a negative under the root sign? Does it change to a positive? Does it depend?
It has to be a fraction.
Logan's got it right. Yeah, it depends on your index. Depends on that little number. So if we look at this one, we're gonna do C up here real quick. -2 times the cube root of 5. If we follow our rule, the -2 comes underneath the sign. So we got the root 5 times, and this is what's going to make your life easy in this unit. Use brackets. So you're going to go bracket -2 bracket to the power of 3. That's the key to doing fractions as well. Using brackets. And then it's really not too difficult. What's -2 to the power of 3? -2 to the power of 3? Punch in your calculator if you're not sure. I think I'm hearing some answers and I'm not liking them. -8. Right? So it's not 2 times 3. It's 2 to the power of 3. So 2 times 2 is 4, times 2 again is 8. This one would work out to be the cube root of 5 times -8. So it's -40. Yeah, the cube root is -40. If it had been a square, that negative would have gone away. So like Logan said, it depends on the index. Odd indexes, the negative will stay. Even indexes, the negative actually goes away. We're going to skip this slide and go into the hard stuff. The harder stuff, according to the entire radicals. Write this as an entire radical. And I truly believe, and as you move on through math, using brackets is like the ultimate answer to doing this kind of stuff. When you forget to use brackets, where things get really confusing. -2 times the 4th root of 3/4. I've told you guys bring the -2 under it and then put it in the power of something. But I also want to use brackets. So this becomes 4 root of, and I'm actually going to keep my fraction in brackets too, just because it keeps things organized for me. This is a good example because it shows what happens to that negative sign when the index is equal. Remembers BEDMAS. Yeah. BEDMAS always applies to everything. I have a sign that tells it in a different way, but it's like, please excuse my difference. The P is for parentheses instead of brackets. I guess that's how Americans. They don't call it brackets, they call it parentheses. Which is weird because Americans are late. So usually they take the easy way out, but we take the easy way out, call it brackets. Anyway. What's the -4 to the -2 to the power 4? What is it? 16. root of 3 over 4 times 16. Yeah, so there's two things you can do here. You can leave your 16 like that, where it's just a 16. Or if it makes your life a little bit easier and you like multiplying fractions by fractions, it's just 16 over 1. Either way is fine with me. 16 is the exact same as 16 over 1. But if that makes your life easier to multiply fractions, I don't care. That works for me. How do you multiply fractions? So over here in the red, 3 over 4 times 16 over 1. Multiply the top together, multiply the bottom together. So 3 times 16 is 48. 4 times 1 is just 4. Multiplying fractions is the easiest thing you have to do with fractions. You can just multiply the top, multiply the bottom. Life's easy. When you're adding fractions, subtracting fractions, it's a little bit more complex. Run it. Which is just 12. Yeah. So hopefully things like that pop in your brain. It's just 12. Yeah. Yeah, that's another way to look at it. Good job, Evan. So 3 over 4 is just 75%. He's changed percent by 0.75. And since you're multiplying it by a whole number, it's just 0.75 of 16. That's a different way of looking at this question. It gets to the same place, and that's fine. It's 12. So we're doing the fourth root of 12. That would be your final answer. That's a good question. So, how many of you guys have ever seen this in your life, where you square root something? So people say you square root 4, and they say it's equal to plus or minus 2. Is that new to some people? New to most people? Okay, the reason you do that, and I think I've shown some people this before, is because if you wanted to get back to 4, what would you do? If you wanted to go from here to there, you would square it, right? So if you square negative 2, it's equal to just plain old 4. Long way of saying, leaving the negative, you actually left the negative by doing that. Because when you fourth root something, if you even root anything, it's a positive or a negative answer. It's not just a positive answer. We're used to just giving the positive answer because it's easier. It's actually a positive and a negative answer. Because you can work backwards with a negative and still get it. Which is why negative 2 squared is 4. Yeah, so if you had negative 2 squared like that, that would be negative 4. Because that's saying just square it. A lot of confusing stuff with rules all coming at you. It'll all come back. It will come back. Have faith. The main part is knowing how to convert these radicals. We'll do some questions together as a group one more time, and then I'll give you guys some time to do some practice. So that you're feeling a little comfortable. That's why we didn't want to do too much on the first day. So you practice, get your feet wet, and kind of build that confidence once you do the practice on your own. You remember more than you think you remember. This first one, convert it into an entire radical. Bring the 3 under the root sign. So now you got the root of 7 over 3 times 3 squared. This first one's, oh, that's it. The writing is pretty difficult to see, right? So it almost looks like the cube root of 7 over 3. This is 3 times the square root of 7 over 3. The best way to either questions, it'll be very clear if it's an index or if it's a coefficient. Like if you look at this question, you can very clearly see that 4 is way smaller than the other numbers. It'll be clear which one, if it's an index, it'll be way small. It won't be just a little bit small. 7/3 times 3 squared. So we're going to do the square root of 7/3 times 9. Fractions are easy, just do the top and the bottom separate. 9 times 7 is what? 63. So the square root of 63 divided by just 3. 3 times 1 is 3. Yeah. 63 divided by 3 is 21. So it's just the square root of 21. Couple more together. Make sure everyone's got it. -2/3 times the root, the square root of 5/8. The square root sign's going to stay the same. 5/8 stays the same, but it's in brackets. You're going to multiply it by -2/3, which is squared. Here we got a little bit of a problem. Yeah, so the negative stays with it, it comes into the brackets with it. So if it was even, you could leave the negative outside the brackets. You can really leave it outside and it's okay, because it's going to cancel out one way or another. But that might be a good way of reminding yourself that it's positive or negative. The square root is positive or negative.
That's just on this term.
She left the negative out.
So like leave it.
Yeah. You can do that if you want. If that's like a reminder to you to just leave it out, you're going to be okay. It's not going to kill you. Just leave the negative out. Because they cancel it anyway. I'm going to do this over here just because we're running out of space. But just to remind you guys, how to apply exponents to fractions. What do we do? Who remembers the exponent law here? Megan, yeah, give it a shot. Yeah, so remember your exponent here? It distributes to the top and to the bottom number. So this is equal to the same thing as -2 squared divided by 3 squared. I just paired that negative. Go with either one. Which means it's equal to 4. Okay, jump back over here. Those exponent laws that you guys learned last year, they're really supposed to just kind of be automatic now, which is tough. So I'll try whenever possible to kind of remind you guys of some of them. That's one of them that's going to be important. Exponents on things that are multiplied or divided, the exponent just goes to all the numbers. Okay, so we got the square root of 5/8 times 4/9, which means the square root of 5 times 4 is 20. 8 times 9 is 72. Think you should leave your answer like that, or no? So we don't want a decimal. We're going to always avoid decimals. But I heard a few people saying we want to make it the smallest or simplest fraction possible. So 20/72 simplifies to be 5/8. 5/18. Thank you. So 8. Do you guys know how to math frac? Okay, that's like math frac everything. Put into a decimal, math frac it. That'll give you your simplest fraction every time. Good? Okay. All right, last one. Let's see if this erases. Okay. Negative 2/3 times, and I think that's a cube. On your page, can you see what cube root? Awesome. So let's do it. We go square root of 2/3 times negative 2/3.
It isn't a cube root.
What is it?
It's just a normal square root.
Which question?
Oh, that one. Okay.
We're good.
Okay.
Cube root.
I know.
The only difference here is that you're cubing instead of squaring. So it's not much more complicated. You're going to have the cube root of 2/3. The first one stays the same. The second one, following our rule, right? 2 cubed is 8. 9 cubed is 27. Sometimes shot in the dark. Multiply the top. Take it one up. Oh, good call. It is negative. Okay. Did you ever see little things like that? I'm gonna forget them. Just let me know so I don't throw you. Like if you're there, like why is that like that? I probably just forgot. Okay, it happens. Okay. Go ahead and do that one. 2 times 8 on the top is going to be negative 16. 3/27 on the bottom is going to be 81. Are we happy with 16/81? Yeah. Yeah. Should be happy with it. Okay. Anybody stressed out? Just doing it without the calculator? Oh, that'll make it hard. Any questions? Okay, I'll give you some time to work. You guys should be able to finish.